Now that we've gone through the position versus time graph, we'll go through the velocity versus time graph for problem 1 from the position and velocity worksheet. Now, if you remember, velocity is going to be the slope that we find of each region on the position versus time graph. Because of that, we can go and take a look at any straight portions. So anything that's a straight line on that position versus time graph, find its slope, and it should tell us the velocity over that same time range. Again, it's going to be a good idea to start off with labeling our axes, and so we've got the velocity and time labeled. We know our time will be in seconds based on the fact that it's going to be exactly the same as what we did before. We'll label that again up to 30 seconds because this is going to be covering the same time span that we covered with the position graph. So keeping it the same, I'm going to label it by the 5s, working my way up to 3 so that we have enough space to cover all 28 seconds of the graph. We've also done some work previously to figure out what the speed was at various portions of the graph. So if we refer back to the calculations from the previous video, and so those up here, we can see that we've got the original speed. So that was the speed for the first region of the graph. And we've also got the new speed. That was the one for when I traveled just to the center point of the board, so halfway across the board. So based on these were calculated again using our speed formula, and they do correspond to the slopes of the regions of the graphs if we go back to that. So we can see that the slope of this first region over here is about 0.83. The slope of this region would calculate out to 0.42. Now, as for the region from 6 to 12 seconds, we can see that that one is sloping down, but it is the same rate, we said, as the first portion of the graph where I was walking across the board originally. Because of this, we know that the value will be the same, but the sign will be different, so we can call that negative 0.83 for that slope. At this point, we've essentially gotten through most of what we need. We just have 2 other regions that still have yet to be labeled with their slopes, and they're not too bad. Both of those regions are points where I was standing still. Because of that, we know that the velocity will be 0 because I'm not moving. And also we can see that since those regions are completely flat, they should have a slope of 0 if we calculate it. Having gone through this, we now see that we've got all of the velocities across the graph, which should be very helpful when putting together our velocity versus time graph. We can also see that these values span from about -0.3 lowest up to positive 0.83, and so that should tell us that we can leave a little bit more room than that just to make sure that we can cover everything, but not too much since we want to make sure that our graph shows the differences clearly by being large enough on our scale. So I think a good point to cut off at would be around negative for this and up to positive 1 on the opposite end, and then we can just do some increments in the middle to help us measure things in between them. And so since I've got 4 regions leading up to each -1 and +1, each of these will correspond to 0.25. Now that we have that shown, we can start to graph this. We know that we are starting in that region with positive slope, and the slope is equal to 0.83, which means that we should show our first point at right about 0.83 on time 0. So that'd be somewhere about there. We can estimate, as long as we're showing something reasonable, that should be acceptable for the purposes we're doing here. We know it's going to maintain that speed for the first 6 seconds. We can see the 0 to 6 second region contains points all going at that same slope. Because of this, we can continue the graph up to 6 seconds, keeping right at the same level. So essentially a horizontal line until we get up to 6 seconds. Should be about there. From there, between 6 and 12 seconds, we see that the slope goes down the opposite way. So we go to negative 0.83, which means we will come back to the opposite end, going to the negative end of the spectrum, starting at about 6 seconds and going until about 12 seconds. Again, just trying to show this as well as we can. And we'll have the second portion of our velocity versus time graph. Following this, we know that it goes back to 0. The velocity will be 0. And we see that it stays at 0 from 12 to 17 seconds. So that means we're going to be graphing that right along the time axis. So it'll overlap a bit there, so I'll broaden this out a little bit so we can see which portion is actually included in the graph, which will be the part that I've shown there, a bit broader. And so that will actually be part of our velocity graph. You see, between 17 and 23 seconds, we're now going at another positive velocity, this time 0.42 seconds. And so we go up, starting at 17 seconds to about 0.42, which I'll estimate is here. And again, it maintains that all the way through to 23 seconds. And so we'll have another flat line there. At 23 seconds until 28 seconds, we see that it's staying still again. And so that's going to bring us 0 velocity, so right along the time axis again, so I'll liken that up. So we can see that this goes until 28 seconds. And with that, we've completed the velocity versus time graph. One thing that we should note here is because the positions were shown in meters and the time was shown in seconds, that these velocities are in meters per second, so we'll note the units over here as well. One question that a lot of people bring up is how long to show each portion on the velocity versus time unit. And the answer for that is that the time matches the time of the region on the position versus time graph. So going back to one example, let's take the region where the slope was negative 0.83 seconds. Negative 0.83 meters per second. We can see that that goes from 6 seconds until 12 seconds. That is all sloping at that same rate on the position versus time graph. And that's how I decided to graph it on the velocity versus time at a value of negative 0.83 from 6 to 12 seconds, so that that region matches up to the same time portion in the position versus time graph. So that should complete our position and velocity graphs for this problem.